This is Jamb Waec 41. You are welcome to this channel of excellence. In this video, I would like us to solve this jump question, right? This problem, clearly the data provided shows that it's gas law related problem. Let us read through and find out the particular law of interest that we are going to apply here. 50 cubic centimeter of gas was collected over water at 10 degrees centigrade and 765 millimeter of mercury. Calculate the volume of the gas at STP, that is at standard temperature and pressure, if the saturated vapor pressure of water at 10 degrees centigrade is 5 millimeter of mercury. Now, from this information given, the fact that the gas was collected over water, they gave us the saturated vapor pressure of water. I think Dalton'S law of partial pressure comes into mind. And what does the law state? That if you have mixture of gases that do not combine chemically, the total pressure that is exerted is going to be equal to the sum of the partial pressure of the component gases. Now, in this question, the gas was collected over water. The water has its own vapor pressure. And as we know, vapor is gas-like. So we now have the gas, we have the vapor. So both the gas and the water vapor are operating together. But as we know, gas and water vapor won't mix. Therefore, the total pressure there, which of course in this question was given, that total pressure will be equal to the pressure of the gas and the pressure of the water vapor. The pressure of the water vapor, saturated vapor pressure of water was given there. Let us deal with this question right away and see. So we have our solution. Now, the parameters given to us, we have initial volume V1 is equal to 50. V1 is equal to 50 cubic centimeter. And then you find out that the initial temperature, T1, is equal to 10 degrees centigrade. You are required to convert this 10 degrees centigrade to Kelvin by adding 273 to that 10. If you add 273 to 10, you will get 283 Kelvin. That's cool. Then again, you find out that we were given the pressure. The time when the gas was collected over water, the pressure was given to us. The pressure there is 765 millimeter of mercury. Please take note. That pressure is the total pressure. That pressure is the total pressure. Permit me to use P subscript T. Total pressure, and it's given as 675 millimeter of mercury. So you see how I'm showing you all this data, the parameters provided. You should be able to determine the parameters when you are seated for your exam so that you know what you are solving. You should know them. You mustn't write them out as I'm writing them out, but you are expected to know them. Okay, let us move on. We are required to calculate the volume of the gas at STP. That is, we are to look for final volume V2. But this final volume is at standard temperature and pressure. Since this final volume is at standard temperature and pressure, it means that the temperature, final temperature at that point, will be our standard temperature, which is 273 Kelvin. And again, our standard pressure is going to be applied here as our final pressure, P2. And that, of course, is going to be 760 millimeter of mercury. These are standard values. At STP, standard temperature and pressure, pay attention to this. Temperature has the value 273 Kelvin. Pressure has the value in millimeter of mercury as 760. Volume of a gas at that point is 22.4 dm3, by the way. So if we are asked to find the final volume at STP, it means that the final temperature, T2, is going to be 273 Kelvin. And then the final pressure, P2, in millimeter of mercury, the value is 760 mmHg. This is the information that we have here. But see, we have a problem. And the problem is that we don't know the pressure, the initial pressure of the gas. Now, if you look at the data given to us, we know the initial volume V1 of the gas is 50 cubic centimeter when it was collected over water. The initial temperature is 10 degrees centigrade, which we converted and got 283 Kelvin. Of course, by adding 273 to the 10. That pressure, 760 millimeter of mercury given, please, dear student, take note. That pressure is not the initial pressure of the gas. When dealing with problems like this under Dalton's law of partial pressure, that pressure given is the total pressure of both the gas and the water vapor. What I'm saying in essence is that the pressure of the gas we don't know. If I call it P subscript G, and you add it to the pressure of the saturated, the pressure of the water vapor given, which is 5 millimeter of mercury, you are going to get the total pressure, which was quoted to be 765 millimeter of mercury in this problem. So look at what I am saying in essence. Let me show you. Pressure of the gas, that's the initial pressure of the gas, which I'm going to label as P1G, or simply P1. Please, P1 is the pressure of the gas. In fact, let me indicate it. Our P1, which is equal to the pressure of the gas, is going to be equal to the total pressure minus the pressure of the water vapor. Minus the pressure of the water vapor. Let me use P subscript W. Please take note. Total pressure. The total pressure of the gas. The total pressure of the gas, PT, will be equal to pressure, the total pressure that's, of the system of gas and water vapor. That total pressure is going to be the pressure of the gas. It's going to be the pressure of the gas, I'm using PG, plus the pressure of the water vapor. So you want to take note of this, PW. Pressure of the water vapor. Now the pressure of the gas, PG, is our P1, the initial pressure here. Is that okay? Is the initial pressure, because our P2 final pressure is 760 millimeter of mercury, which is the standard pressure of the gas. So for us to obtain the pressure of the gas, which is our initial pressure in this case, is going to be the total pressure minus the pressure of water. Pressure of the gas, which is our initial pressure in this case, is the total pressure minus pressure of water vapor. So that is why I'm using this formula to get our P1. And if you substitute, the total pressure is equal to what? Total pressure was given to be 765 millimeter of mercury. You can see that here. Are you following? Then the pressure of the water vapor, you can see that saturated vapor pressure of water is 5 millimeter of mercury. So the pressure of the water, which I have here, is 5 millimeter of mercury. This is going to be minus 5. If you simplify this, the implication is that the initial pressure of the gas, P1, 765 minus 5 is going to give us 760. It's going to give us 760 millimeter of mercury. So you want to take note of this, please. Dear student, you should be able to determine your data, all right? Bring them out. Very important. Okay, so let us proceed in our solving. With this information given to us, we know our P1 now. We know our P2. We know our T1. We know our T2. We know our V1, but we don't know V2. So this will require that we use general gas equation. As a matter of fact, this problem that makes use of Dalton's law, because we needed to add the partial pressure of the gas and the partial pressure of the water vapor to get the total pressure. So there is an application of Dalton's law of partial pressure here. So in solving this problem, using the knowledge of Dalton's law of partial pressure to get our initial pressure, after doing this, looking at the whole information given to us, it will require that we use general gas equation, where we know that P1 times V1 over T1 is equal to P2 times V2 over T2. So with this formula, we're going to substitute and get V2. If I decide to make V2 subject to the formula directly, you would notice that it implies that V2, which is the final volume we are looking for, is equal to P1 V1 times T2, and it's going to be divided by P2 times T1. If I do the substitution, the final volume V2 is going to be equal to our initial pressure of the gas is 760, and then it's multiplied by V1. Our V1 is 50 cubic cm. We are multiplying by T2. The T2 is 273 Kelvin, and this is going to be divided by P2. Somehow, some way, the final pressure, which of course is the pressure at STP given by the question, is still 760 millimeter of mercury. Multiply it by T1. Our T1 is 283. So what we need to do is to reduce this term. 760 will divide 760, it goes off. So we now have 50 times 273 divided by 283. Okay, if you multiply 50 by 273 and divide by 283, this gives us 48.23. The final volume of the gas is equal to 48.23. 48.23 cubic centimeter. So this is actually the final volume of the gas. This is the final volume of the gas. I want to make a conclusion because it's not necessary in your Jamb exam. In Waec, you have to make a conclusion. All right, the volume of the gas at STP is equal to 48.23. Cubic centimeter. That's the answer. That is the answer. The volume of the gas at standard temperature and pressure is equivalent to 48.23 cubic centimeter. You see, this is how simple, how we solve the problem. I think key areas that students want to take note of is what I did here. Key areas that students want to take note of is what I did when I was trying to determine the initial pressure of the gas. Look at this. Take note of it. Very important. Because this is the gray area in this question. This is a gray area. How to use the knowledge of Dalton's law of partial pressure to obtain the pressure of the gas when the gas is collected over water. Like I said, the pressure of the gas plus the vapor pressure of the water will give you the total pressure of the system. And in our question here, the total pressure of the system is 765 milliliters of mercury. It was given in the question. It was given in the question. You can see that. All right. The total pressure, it was given 765. Then, of course, the vapor pressure of water, saturated vapor pressure of water was given, subtracted from the total pressure, and you see you get the pressure of the gas itself, which according to this information given, the pressure of the gas itself is the initial pressure. Once you do that, your problem is as good as solved. All you just have to do is to apply your general gas equation. So don't forget your general gas equation as used here. Whenever problems are given to you in this format, you also need your general gas equation, and look at it. Those are the two key equations you need to blast this problem, just like I have solved it. Very simple, there is no big deal. To learn more about gas law, you can actually go through the sections of this channel under the playlist or the course sections. The playlist or the what? Course sections. You're going to see the section dedicated to Jamb Chemistry, Waec Chemistry. Click on that playlist. Once it opens, you see video lessons, on different aspects of chemistry, including gas laws. You can learn more about gas laws from there. I'll be seeing you in the next video. And of course, if you're yet to subscribe to this channel, hit the subscription icon right now. Turn on the notification bell and select all so that once I upload any content or come on live, you'll be notified by YouTube. All right, I'll be seeing you in our next class.